So, using some basic assumptions, we have just now derived this mass radius relation for white dwarf. Okay. Basically, we are discussing the white dwarf. Previously, we derived the degeneracy pressure. Afterwards, we used hydrostatic equilibrium equation and constant density to derive the central pressure for a white dwarf. Next, we are using the same old, these two things we are combining, and then we get this mass radius relationship for a white dwarf. Okay. Now, if you look carefully, radius inversely proportional to m to the power 1/3. So this means that you see there is something like this, or mass into volume is constant. So what does this mean? So this is a box, right? So according to this model, whatever is here, mass into volume is constant. So if I put more and more stuff into this, if I am putting more and more stuff into this, so its mass is increasing. So according to this expression, its volume should squeeze. Can you imagine such a thing? As if I am putting more mass into it, it is keep on squeezing. Do you see anything like this anywhere near us? No. In our normal life, anywhere. Say for example, this bottle. This is a water bottle, right? Suppose this is empty. According to this model, if I put more water into it, it will squeeze. Its volume will decrease. Have you ever experienced such a thing? Never. Now, first question. Why?
So there are no fusion in water.
No. Don't think about fusion or anything. Normal matter doesn't behave like this. You have to understand the very basic difference. Remember last day I was talking about normal star. What happens during the scenario of hydrostatic equilibrium? We have the equilibrium between gravitation and kinetic pressure. That's it. What happens in a white dwarf is entirely different. Here, as the gravitational force is dominating and keeps on collapsing the entire star, assuming the kinetic pressure is not sufficient, which happens after there is no fusion, fusion has stopped, then what happens? At first, out of all the particles inside, the electrons, their de Broglie wavelength become close enough to that of their mean separation for the electrons. I'm not talking about other species. Okay. Then, when such a thing happens, this means the electrons inside the white dwarf, they start behaving quantum gas, like a quantum gas, instead of previously behaving like a classical gas. Now, if I am talking about quantum gas, then I have to understand that electrons are fermions. Pauli's exclusion principle is there. So this means they cannot be put down in a state where all of them have the same quantum number. Indirectly, this means that they will not agree to the terms and conditions of the gravity pushing them towards a single state having all the same quantum number, right? So this negation that I will not obey your demand, gravity. This statement in a way generates degeneracy pressure. This is the origin of degeneracy pressure, right? Now, so here we are talking about degenerate matter. This is not normal matter. This is white dwarf. Remember? This is white dwarf. This is not normal matter. Okay, first thing. So that's why we don't see anything like this, because this is normal matter. This is classical scenario. There is nothing quantum, no violation of fermionic nature, no Pauli's exclusion principle directly coming into play. So you don't see the volume squeezing. Number one. Now, look into, so basically the entire thing happens due to the degeneracy scenario. Okay? Understood this point? Now what happens is that, let us compare two white dwarfs. It will become more clear. Suppose this is a white dwarf having mass m, right? Next, this is another white dwarf having mass twice m. Of course, its mass is more, so it will be more voluminous, right? It has got larger volume. Fine. Now what happens? In both of them, we are talking about hydrostatic equilibrium. That is, degeneracy pressure will equate the gravity. Now in this case, compared to this case, the electrons will be squeezed much more. Then only they can generate enough degeneracy pressure which can withstand gravity. Understand? So here, to withstand the enormous gravity, here gravity is more than this. This you understand because the mass is more. Now, to withstand this enormous gravity, the electrons will have to come even more closer to each other. Otherwise, they will not be able to generate the required even more degeneracy pressure than this case. বুঝতে পারছো? এইখানে অনেক বেশি degeneracy pressure is required. More degeneracy pressure is required in this white dwarf. And to generate that, the electrons have to come closer. That means this star or this white dwarf, where is the duster? Yes. So this white dwarf will in fact will have even more smaller size. Because this is the way in which the larger degeneracy pressure will be generated, which will counteract this even more gravitational pressure. So this is the origin of this feature that you don't observe normally. You have to understand. I will be asking this question in the examination. So this is how you will explain. This is why we don't see this normally. Because we are not talking about degeneracy pressure in normal life and also in normal stars. Say for example in the sun. Do you see anything like this? No. Because there also the degeneracy pressure is not playing the role right now. Okay? Any questions?
No, sir.